So today we're going to be having a look at translating these power functions. And basically what we're going to look at is this form here, which looks a lot like the turning point form of a quadratic. And in fact, it's basically the turning point version of all of these different ones. So let's set b to 0. Let me change all of these steps so they're a little bit easier to work with. Let's make this 1. And let's make this one also 1. And let's just move them to the origin. Alrighty. And we can see that it plays just like before. Oh, let me change n. We do not want n to be anything other than going up in steps at 1, 1 up to 10. Alrighty, so let's just look at the quadratic. Right, obviously we've worked with the quadratic before. We understand how turning point form works. And remember, a just changes whether it's concave up or concave down. But does this all still work for other functions? Let's have a look at the cubic. Well, for the cubic, okay, it moves not a turning point because the cubic doesn't have a turning point. It has this point here, which we call the point of horizontal inflection. Alrighty? So this is what we can call the point of horizontal inflection form of the cubic. So it's a really quick way of sketching simple quick cubics without having to work very hard. What do we think is going to happen for quartics? Well, quartics behave very similarly to quadratics. So we'd expect the behavior to match. Oh, it does. It's basically the turning point form, except it's literally the turning point form. Once again, this changes around here. A value just slides back and forth. But for B and for C, it's literally just moving around that turning point. Just going back to cubics for a second, if I do make A negative, it just changes whether it is increasing or decreasing. Just like before, B and C control where that horizontal point of inflection is. So let's take some notes. Alrighty, so for a cubic, a power cubic, so that's something of the form y equals a x minus b to the 3, because it's a cubic, plus c. B comma c is the point of horizontal inflection. All that means is that at that point, the gradient is flat. Basically, it's looks like this, just for a moment. And so if I put it on some fake axes, that point there is where it changes from being concave up to concave down, or vice versa. That's the idea. So that's the point BC. And once again, A positive will mean increasing, while A negative will mean decreasing. Alrighty, same thing for the quartic. It's basically identical to the turning point form of the quadratic. So BC is the turning point. Now to draw a quartic as opposed to a cubic, compared to a quadratic, is that it just has a much flatter bottom and a much steeper change. That's a negative a value quartic. Let me make it positive. All right, where this is B comma C is the turning point. And once again, similarly to before, when A is positive, it's concave up. And when A is negative, it's concave down. Alrighty. So now that we've got a little bit of understanding, let's see what we can do with that. Alrighty, so having a look at this graph, we can see, first of all, that it is going to be a cubic. So n equals 3. And we should also note that A should be negative as it is a decreasing cubic. So with that little piece of information, let's go through. So y is equal to a x minus b to the power of 3 plus c. B, comma, c is the horizontal point of inflection, which is this point here, which is 4, 2. And so we now get y is equal to a x minus 4 to the 3 plus 2. Note, minus b, so it still does swap the sign of whatever the x-coordinate of the turning point is. In this case, point of horizontal inflection. Now we've just got to sub in a point. We've got 2 points to choose from, 1, 11, or 7, negative 7. I'm going to go with 1, 11 because that's the easy one, so let's sub in 1, 11. 11 is equal to a 1 minus 4 to the power of 3 plus 2. Alrighty. Order of operations means we get 11 is equal to a 1 minus 4 is negative 3 to the power of 3. Negative 3 to the power of 3 is negative 27. So this becomes negative 27a plus 2. Subtract 2 from both sides. And we're left with 9 is equal to negative 27a. Divide both sides by negative 27. And we are left with a is equal to 9 over negative 27. Well, 9 and 27 both have a common factor of 3. Negative stays. And that would be our final a value, which is what we said at the beginning because we thought an a should be negative, and we get negative a third x minus 4 to the power of 3 plus 2, and that is the equation of that line. Same thing for a quartic, except instead of to the power of 3, it'll be to the power of 4, and instead of the point of horizontal inflection, it'll be the turning point. See you in the next one. Goodbye.